Hi, my name's Abe, and today we're going to go through an example where we talk about the average value of a function. So here goes. A car's velocity in kilometers an hour as it accelerates is given by v of t equals 200 minus 10,000 over t plus 50, where t is positive. What is its average speed in the first 5 minutes if t is measured in seconds? Alright, whole bunch of words. This is what you want. What you want is to see what this graph looks like. So here goes. If this is our graph, we know that there's some kind of asymptote at v equals 200, right? You should know that. That's not too difficult. And if we draw it, it's going to look something like this. It's going to be quickly rising and then kind of just approaching the asymptote like that. Let me fill in my line. You know what I mean. Okay. So that's v and that's t. And we are interested in what happens in the first 5 minutes. Alright, notice that t is measured in seconds. So 5 minutes is 300 seconds. So let me just put 300 here. And this is the period we're interested in is from 0 to 300, right? And we're after the average speed. So there's a couple of ways to think about this. The first one is this, that, well, what's an average speed during this period? Think of maybe there's another car during this whole time that was going at constant speed. So if this car was going at constant speed, what speed would it be going at for it to be at the same spot as the first car? So maybe a line that looks kind of like that. So what's that speed? So what you're interested in here is the area under our graph. So you know that this area here represents distance traveled, right? And if we were to go this first kind of approach, what we're saying is, well, maybe the rectangle between 0 and 300 and that green line, we want the area of that rectangle to be the same as the shaded area. So try to write that in an equation. And what you're going to get is, alright, so you know the area is going to be, what? 300, because the x-axis runs from 0 to 300, times some kind of speed. Now, that speed is something we don't know. But we do know that we can find that speed by saying s equals 1 on 300 times what? The area, right? And what's the area? The integral of v of t dt. Yeah? So that's one way. We can think of it that way. That's not too bad, right? So that when we calculate that, that's going to give us the average speed. Now, the second way of thinking about it is really simple. You just say average speed is obviously equals distance over, oops, not that, distance over time, right? So we ignore this second car altogether and we say, alright, distance over time. What's the distance? Distance is obviously the integral v of t dt. Oh, I should put terminals on my integral. 0 to 300. 0 to 300. And, oh, divide by time. How long is the time period? 300 seconds. 1 on 300. So, you see that using both methods, we come to the same integral, which is really good. So, this is essentially most of the work in solving this problem. Now, all you got to do is evaluate the integral. So let's do that. So what we're saying, we know that the average speed, let's call it s, is equal to the integral between 0 and 300 of v of t dt. Now v of t is 200 minus 10,000 over t plus 50. T, like that. Great. So we evaluate this integral and we're done. Not a hard problem. So let's go ahead. So this equals, oh, beg your pardon, 1 on 300. Almost forgot. This equals 1 on 300. Now, 200 just becomes 200t when you integrate, and 10,000 over t plus 50. Well, you know what to do with 1 on t plus 50. It's a log to the base e of t plus 50. And your terminals are 300 and 0. Your calculator can help you out here, but I'll just walk through it very quickly. So that's 1 on 300. Now, you've got 200 times 300, 60,000, minus 10,000 log to the base e of 350, putting in t equals 300. Now you minus, what happens if you put in t equals 0? So 200 times 0 is 0, and you want to minus the next term as well. Two minuses, 10,000, oops, one more 0, log to the base e of 50. Like so. Great. So simplify that out for yourself, and what I'm going to do is actually take 10,000 out of that bracket. So 10,000. So inside we've got 6 minus log of 350 plus log of 50. Simplify that a bit further, and you get 100 over 3, 6, and you can combine the two logs using some log laws, minus log to the base e 7. So 7 is 350 divided by 50. And that's it. That's an exact answer. And the speed is in kilometers an hour. And if you wanted to quickly check what the speed is, put that into your calculator, you'll get 135.14 kilometers per hour. And that's it. So all the work was in setting up the integral, and in working it out, well, I worked it out by hand, but you can probably use a calculator to do it depending on what kind of answer they're after. So I hope you found this helpful. I'll see you in the next video.